3.6 rational equations you have all down right now. So we're going to start. Please put the fidget spinners away. Thank you. I want to just start off with a question, and then I want you to take a minute to think about it, and then you're going to talk with your partners. What is the difference between solving and simplifying? You don't need to write this down. Just take, I don't know, let's look. We have the timer on the board here. Let's take 10 seconds just to think about it in your head, okay? And then we'll raise hands. I want to give everyone a chance here to think about it. I have so many awesome volunteers, but some people take another minute to process.
Wait, I just have a question.
Yes.
The goal is simplifying rational equations.
Solving.
Oh, sorry.
Okay, talk with your partner for a second. What's the difference? Okay, we're gonna start 5, 4, 3, 2, and 1. All right, Gunnar, yes.
So solving is getting an answer, simplifying is getting the simplest answer. So like 6/8 could be a solution, but like the simplest solution would be 3/4.
Okay, I like that. So Gunnar said solving is getting an answer. So you could get like 6/8. Simplifying is getting the simplest form. Okay, so 6/8 can be simplified to 3/4. Can anyone else add to it or a different spin on it?
Solving is getting like a direct solution.
Okay.
X equals 10.
X equals 10, a direct solution. Okay, for solving. What about simplifying?
Simplifying is getting it as close as you can to making it equal something without knowing the correct answer.
Okay, so Evan said getting it like equal to as close as you can get it, the smallest form, but you might not have a direct answer, okay? Yes, Sierra?
So like making it easier to get the answer. Like if you simplify it, it's easier to solve.
Okay, so if you simplify it, it might be easier to solve eventually, yes.
Solving could be like getting an answer that has, like Evan said, like a direct thing to it. But simplifying is just taking an extra step and breaking it down further.
Okay, good, I like it. I heard something from Grant that I liked what he heard. Grant? Okay, what did you say about expressions? Tell me more about that. Right, so when you simplify, a lot of times you're simplifying an expression. There's no equal sign with it. When you're solving, we're doing a lot of what you guys said. Okay, listen up. When you're solving, you have an equal sign where you need an answer and you may need simplification to get there. Okay? So the goal today is solving. We will be getting an answer, and let's get started. I want to remind you about cross multiplying. You may see a problem like the problem below. Example 1, we're going to call it 3 over x plus 1 is equal to 9 over 4x plus 5.
Just simplify 3 over x plus 1. So that you can see it. Because they equal the same thing.
Okay, I'll chat about it here in a second. Okay? When we're cross multiplying, back to the basics, just a friendly reminder. A times B is equal to B times C. So you can use cross multiplication today to get to your final answer. So let's do that now. Does everyone have 3 over x plus 1 is equal to 9 over 4x plus 5? Get it written down. While you're writing it, notice we just have a fraction is equal to another fraction. So I'm going to cross multiply here. I'm going to take 3 and multiply it times 4x plus 5. And I'm going to take 9 and multiply it by x plus 1. Now, I know some of you could probably do that in your head, but there are lots of mistakes that happen when people do that in their head. So some of you could jump right away and say, oh, well, I know that 3 times 4x plus 5 is 12x plus 15. Because you can distribute that just by looking at this oval here. But just pay attention to details. Go slow enough. I see more errors when people skip that step. Okay? The next thing is I have that 9 times x plus 1. And again, some of you can do that in your head knowing that that's 9x plus 9. Now, you guys have done algebra before. I want you guys to solve for x there if you haven't already. Yeah.
Will all our homework answers be whole numbers?
No, they probably won't all be whole numbers. That's a good question. The question was, will all our homework be whole numbers? And most likely not. It is nice. I know, it's clean when you get a whole number. Okay, when I solve this, I do just kind of a little reminder. I like to start with the x's when you're joining them together. Does anyone start with the constants? That's not a problem. I know like Miss Stout does and some other teachers do. I personally have seen in my career more mistakes that happen that way. So I like to start with the variables, combining those together.
I do the like subtract the side negative 15 or minus 15 like I'm putting on the left and then the negative or minus 9x on the right.
Yeah.
Save space.
Right. So you do it all at once. You minus
Yeah.
9x, and then you minus 15. Okay. So we have 9 minus 15, and we get negative 6 is equal to 4. No, it's equal to 3x. And what is x equal to, guys? Negative 2. You are going to want to check your work today. You can just do it in your head. We're not going to do it right now, but I'm just giving you a forewarning. Yep, you can have it the other way around too. Negative 2 is equal to x. That's not a problem. Let's get a little bit more difficult. You guys ready? Okay. No, I'm going to skip this one for today. What do you notice here?
Oh. There's two at one time.
I'm going to delete. I didn't make these notes. This is a different teacher. So hold on there. I'm going to get rid of that. Write this problem down for me. Okay, write that problem down.
Oh, also.
5 over x plus 7 over 4 is equal to negative 9 over x. There are two methods you can approach solving these today. Actually, there's 3. I'm going to show you 2, and if you can figure out the other one, you can do that as well.
Well, you could also just remove 5.
Oh yeah.
Okay. There's a lot of different ways you could do this. Because you'll notice that my x's have the same denominator, what can I do?
You can bring the 5 over here.
Yeah, I can bring the 5x over to the other side. So I'm going to subtract 5x and subtract 5x. And now I have 7 over 4 is equal to negative 14 over x. And now what am I going to do? Yeah, now I'm going to cross multiply. So this is one strategy. If you have several fractions, not just 2 fractions, see if somehow you can manipulate that equation by adding or subtracting to just get 2 fractions. A fraction equals a fraction. And then you can cross multiply. So negative 14 times 4, what does that give you guys? Negative 56 is equal to 7 times x. And we can do that in our head. What is x equal to? Negative 8. Questions? So the first strategy there, okay? try to get it to be a fraction equals a fraction if it isn't already. And how do I know to do that? If you see the common denominator there in the fraction. Okay? Did you guys all see that? If you see the common denominator in the fraction, that's kind of your helpful hint. There's a common denominator already. It's not across the board, but there's a common denominator with two of them. HH, what does that stand for? It stands for helpful hints. All right, we're going to move on to the next one, unless there's questions. Okay, here's one now. There's not a common denominator in two of the fractions.
Oh yeah, wait, can you say something you did in the last one?
We can, but I want to show you a different strategy now, okay? Well, hold on here, okay? So, I'm going to show you a different strategy now. So, yes, could I bring the 1 over here? Most certainly. And get a common denominator, scrunch it together, and cross multiply. But I've already showed you that strategy, and my job as your teacher is I want to give you a bunch of different tools, and you can kind of evaluate the situation as you go. I'm not going to tell you to use one strategy. On the test, I'm just going to give you the problems. Okay? This strategy, what I want, okay, is I want you to make it 1 over 1. And what we're going to do is we're going to get a common denominator across the board. Okay? A common denominator across all the fractions. So I wrote a 1 over 1 because I want to see it as a fraction. What is my common denominator going to be? X minus 5.
Well, x squared minus 5x.
Okay, don't leave it as a factored form, not together.
X times x minus 5.
X times x minus 5. Why did I pick this problem here? What are people going to want to do with that x? Subtract 5. You can only get a common denominator through what? Multiplication. So I have this x times x minus 5 here. This one needs an x, right? And this one needs what? Both. Yeah, x times x minus 5. Now, because I have common denominators across the board, what I can do is I can cross them all off. Okay? And the reason it is, if you think about it, okay, the reasoning, you don't have to write this down. Watch carefully. If I have 3/4, right, plus 2/4 is equal to 5/4. Do you see how I could cross that all off? And it's the same, because if I smoosh this together, that's 5 over 4, which is equivalent to 5 over 4. And I don't care about the denominator, I only care about the numerator as I'm doing this. I want to get rid of the denominator. That's going to help us solve. Okay? So the strategy here is I can, okay, get a common denominator across the board and cross it off. Cross off and solve. Okay?
Okay, if it's 1 over 1, why is there no x on the top?
Because I forgot to put the x. Megan just said if it's 1 over 1, why is there no x on the top? And that's because I forgot to put it up there. Thank you, Megan. So I'm going to cross all of the denominators off. And now what am I left with? I'm left with x times x minus 5 minus 8 times x is equal to 3 times x minus 5. At this time, I'm going to have you solve for x because this is a problem you saw in algebra, okay? But you're going to run into something. What are you going to run into? What? Okay, well, let's finish it together then. I'll have you finish the next one. You run into a little bit of a hiccup, and we need to evaluate now, how are we going to get through this hiccup? What is my first plan of attack here?
You want to get rid of the x minus 5, but it's got another thing attached.
Yeah, it's got a thing attached to it, so what do I need to do?
Divide this thing.
I actually want to just simplify right now. Okay? So I'm going to take x times x, and I get x squared. X times negative 5, I get negative 5x minus 8x is equal to 3 times x, which is 3x, and 3 times negative 5, which is negative 15. Okay? So let me take a little break here so you can kind of let that sink in. So I'm just going back to my basic algebra solving an equation. I need to simplify and isolate the variable. But we're going to combine like terms next. Very good. So I now have x squared minus 13x is equal to 3x minus 15. Now what am I going to do? Okay, I'm hearing a couple different things. I heard pull an x out of an exponent. What else? Someone said
Bring the 13x over to the other side.
bring the 13x over to the other side. Any other things? There's something special about this equation.
Oh, you can make it into a quadratic.
It's a quadratic equation. How do I know that?
Because
Because the degree is 2. Bingo. Very good. The degree is 2. So if you've forgotten that, that's something you have to put away in your brain. Okay, a little muscle memory. The more you do things over and over and over again, the more it's just ingrained in that muscle. Okay? Your brain's that muscle there. Okay? So I'm going to subtract the 3x. And I have x squared minus 16x. Bye, Anna. Everyone say bye, Anna.
Bye, good luck.
All right.
Where are you going?
Back up here.
To the track meet.
All right. Back up here, I have a quadratic, and when we have a quadratic, we need it set equal to what? 0. So that's done. Add 15. That's done. Is equal to 0. And I have a quadratic, and what have I instructed you whenever you have a quadratic to solve it? Factor it first. Do not do the quadratic formula until the last thing. I won't count you wrong, but you are doing yourself a disservice. Why? Because pre-calc and calculus especially are loaded with factoring. Loaded with factoring. So, why did we learn the quadratic formula? For stuff that's not factorable, when we have to solve, we do need it. You just won't use it as often. Yes, okay, ladies and gentlemen, I'm hearing a lot of chatter right now, okay? I totally get a lot of you guys have this down, okay? But there are things you've never seen before that I need to warn you about. So I'm going to take x minus 15, right, times x minus 1, okay? And my solutions are x is equal to 15 and x is equal to 1. Now, especially when you get two solutions, you need to check them. You need to check for extraneous solutions. So we go back to that original problem and we plug them in. I'm going to pause the video at this moment. I'm going to walk around and check in with you while you're checking both solutions. And at this time, if you have any questions, please let me know when I kind of come by your seat.